In our last screencast, we discussed conversion factors. In this screencast, we discussed the use of conversion factors for performing unit conversions. Suppose, for example, that we want to convert 24,700 feet into units of miles. The key to performing a unit conversion like this one is to multiply the given quantity, in this case the 24,700 feet, by a conversion factor that relates the units we're given and our desired units. So we need to multiply by a conversion factor that relates feet and miles. So, in other words, we need to take our 24,700 feet and multiply it by some fraction, that's our conversion factor, so that when we're done, we'll be left with some numerical value and a certain number of miles. So our conversion factor that we need to multiply by has to relate feet and miles. We want to be left with units of miles, so the particular conversion factor we need to multiply by is going to have feet in the denominator and miles in the numerator. The reason for this is because 24,000 feet, if we write that as a fraction, it's 24,700 feet over 1. So the feet here is in the numerator. If we multiply by a fraction that has feet in the denominator, then we'll have feet in the numerator, feet in the denominator, and we've learned that when that happens, we can cancel the feet, and we'll be left with units of miles, which is what we wanted. So you can see we started off with a certain number of feet, and we will finish with a certain number of miles. So again, the key is to take the quantity that you're given and multiply it by a conversion factor that will cancel out the undesired units, and it will leave the desired units when you're finished with the calculation. Now, the conversion factor that you need to multiply by will sometimes be a product of multiple other conversion factors, like we saw in the previous screencast. This will be the case if you don't know what the conversion factor is between your numerator and denominator. But in this particular case, we do know how many feet there are in a mile. We learned that in our last screencast. In particular, there are 5,280 feet in 1 mile. So that's the conversion factor that we need here. So if we look below, you can see we're taking our 24,700 feet, we're multiplying by the correct conversion factor that takes us from feet to miles, and when we multiply these together, we see that we end up having to divide the 24,700 by 5,280. That gives us 4.678. And when we deal with our units, the feet cancel, leaving units of miles. So we have shown in this calculation that 24,700 feet is equivalent to 4.678 miles. So we have performed a unit conversion. Okay, so we need to practice the unit conversion process. And we'll do this in example 3.9. 3.9 has 6 parts to it, so we will get a significant amount of practice performing unit conversions in this example. Okay, so let's look at Part A. In Part A, we want to convert 54,900 milligrams into units of grams. So, we will do this the same way that we did this above. We start off with what we are given. We always start with what we're given, which is 54,900 milligrams. We're going to have to multiply this by a conversion factor. The conversion factor ultimately has to relate the units that were given, the milligrams, to the units we want, which are grams. So we need to multiply by a conversion factor that will have milligrams in the denominator and grams in the numerator. We do it this way so that when we are all done, the milligrams will cancel because you have milligrams in the numerator, milligrams in the denominator, so they cancel and you will be left with units of grams, which is what we wanted. So the challenge for us is to figure out what is this conversion factor that takes us from milligrams to grams. This is where we have to recall what we know about milligrams. Remember from earlier in this chapter that milli, the prefix, means to multiply by 10 to the negative 3. So when we write milligram, we're talking about 10 to the 3 grams. In other words, 10 to the negative 3 grams is the same as 1 milligram. This fact tells us what the conversion factor is for this particular example. Namely, there are 10 to the negative 3 grams in 1 milligram. So, in order for us to calculate the numerical value that goes here, we have to multiply our 54,900 by 10 to the negative 3. We've done that before. Multiplying by 10 to the negative 3 is the same as moving the decimal point 3 places to the left. So we finish with 54.9. So that's our numerical value. So we've shown through this calculation that 54,900 milligrams is the same thing as 54.9 grams. Let's try part B. In this case, we want to convert 2.5 kilocalories into units of calories. Well, we approach this problem the same way we have done the last two examples. We start off with what we are given, the 2.5 kilocalories, and I'm going to use the abbreviation. We have to multiply this by a conversion factor that relates the units we're given and the desired units. So in this case, we need to multiply by a conversion factor that has calories and kilocalories. In this case, we want kilocalories in the denominator and calories in the numerator. We do it this way because then we will have kilocalories in our numerator here and the denominator here, and therefore they will be eligible for canceling. This will leave us with a certain numerical value, and it is given in units of calories. So What we have to work on is figuring out what this conversion factor is. The key to working it out here is to, again, recall that the prefix kilo represents a factor of 10 to the 3. So a kilocalorie is 10 to the third calories. In other words, 10 to the third calories is the same as 1 kilocalorie. So for our conversion factor, we can write 10 to the 3 kilocalories over, or calories over 1 kilocalorie. To calculate the numerical value that goes here, we multiply 2.5 times 10 to the third. We can do this by simply taking our decimal point and moving it 3 places to the right. This gives us 2,500. So we have 2,500 calories. So in the course of this calculation, we have shown that 2.5 kilocalories is the same thing as 2,500 calories. Let's work another example. In this example, we want to convert 2,680,000 watt-hours, abbreviated WH, that's a certain amount of energy, into units of megawatt-hours, abbreviated MWH. Okay, we do this the same way. We start with what we are given. That would be the 2,680,000 watt-hours, and I'm going to use the abbreviated form, and I'm going to write it as W times H, because remember that watt-hours is the product of a certain number of watts and a certain number of hours. We need to multiply this quantity by a conversion factor so that when we are all done, we will be left with a numerical value that has units of megawatt hours. So that's our goal. So we have to figure out the appropriate conversion factor here. Okay, so we want to think about this a little bit. Notice that hours appears in our given units and also in our final units. In other words, with our conversion factor here, we do not want hours to cancel out because we want it to remain in our final units. What we want to happen is we want to lose the units of watts and have units of megawatts instead. So we need a conversion factor that enables us to go from watts to megawatts. So in particular, we want watts in the denominator and megawatts in the numerator, because then we will be able to cancel the watts, because the watts over here are actually in a numerator, because we can put this over 1. So the watts will cancel, leaving us with megawatts when we're finished in our final answer. So what is this conversion factor here? The key, once again, is to recall what the prefix mega means. Mega means to multiply by a factor of 10 to the 6. So 10 to the 6 watts is the same as 1 megawatt. So that's where we get our conversion factor from. 1 megawatt over 10 to the 6 watts. So now we can calculate our numerical value over here, we have to take our 2,680,000, multiply it by 1, which of course gives us 2,680,000, and divide that by the product of 1 and 10 to the 6, which is 10 to the 6. So in other words, to calculate the numerical value, we end up having to take 2,680,000 and divide by 10 to the 6. And this will give us units of megawatt hours when we're done. So if you take the 2,680,000 and divide by 10 to the 6, which is the same thing as dividing by 1,000,000, you arrive at 2.68 megawatt hours. So the 2.68, that is the quantity that would be in that box right there. So we've shown through this calculation that 2,680,000 watt hours of energy is the same thing as 2.68 megawatt hours of energy. Now let's look at part D. We want to convert 4,200 hours into units of days. So we start this the same way by writing down what we are given, 4,200 hours, and we need to multiply this by a conversion factor so that when we are done we will have a numerical value and the units will be days. So our conversion factor here needs to relate hours and days. We know that there are 24 hours in one day, so the appropriate conversion factor would be 1 day over 24 hours. Why is this the correct conversion factor to multiply by? Well, if I write this quantity as a fraction, we can see that hours appears in the numerator here and in the denominator here. So the hours can be canceled, leaving us with units of days, which is what we wanted. So in order to calculate the numerical value that goes here, we have to multiply the 4,200 times 1 and the 24 times 1 and then divide. So in the end we really just need to take 4,200 and divide it by 24. That will give us the numerical value. In this case, that numerical value is 175. So we have shown through this example that 4,200 hours is equivalent to 175 days. Let's take the next example. Here we want to convert a speed, 2.3 feet per second, into a speed that's given in terms of miles per hour. We start the same way as we've done before with what we know. So we take the 2.3 feet per second. Now in this case we want to write the feet per second as a fraction. So it's 2.3 feet divided by 1 second. And we want to multiply that by a conversion factor, a fraction, so that when we're done we will have a certain numerical value given in units of miles per hour. Okay, so the issue now is, what is this conversion factor? Well, if we look at the units that we're starting with and the units we want to finish with, we can see here that there's more work to do. We need to be able to convert from feet to miles and also from seconds to hours. We're not going to be able to do that with a single fraction here or a single conversion factor. This is one of these cases where we're going to need to work with a product of other conversion factors in order to get the conversion factor that we need here. So we're going to break this problem down into smaller pieces, and we'll do it below. So I'm going to repeat this fraction, 2.3 feet per 1 second. Okay, so the first thing for us to do is to get rid of the feet. We want miles, so we need to convert from feet to miles. We do that with a conversion factor that relates feet and miles. We know that 1 mile has 5,280 feet. We learned that from our previous screencast. So this would be the conversion factor, and we know that this is the right conversion factor because notice that we have feet in the numerator and the denominator, and therefore they cancel, and they will leave miles in the numerator, which is what we want. So we have now gotten rid of the feet, and we have miles. Now we need to figure out how to convert from seconds to hours. So we're going to multiply by yet another conversion factor. Most of us maybe don't know how many seconds there are in an hour, but we do know how many seconds there are in a minute. So let's start with that conversion factor. We know that there are 60 seconds in a minute. Oops. I'm going to erase that. 60 seconds in 1 minute. So you can see here, by multiplying by this conversion factor, I've gotten rid of the seconds. I haven't gotten all the way to hours yet, but I've gotten to minutes. So now what I'm going to do is multiply by a conversion factor that will get me from minutes to hours. And I know that there are 60 minutes in 1 hour. And I know that this is the right conversion factor. I don't want the reciprocal of this because I want to be able to cancel the minutes, so I need minutes in the numerator and the denominator. So let's look at what we've got now. When we're done with these multiplying these four quantities together, we'll have miles in the numerator and hours in the denominator, which again is what we wanted. So we know we are done. So multiplying by these three conversion factors gives us this needed conversion factor here. So this fraction right here is actually the product of these three fractions together. So let's finish this off. We need to actually convert the numerical value. So to find the numerical value, we have to take the 2.3, multiply it by the 60 and another 60, and when we're done we divide by 5,280. So when we do that, we arrive at an approximate value in this case. So this is just going to be an approximation here. We arrive at an approximation of 1.6, and the units are miles per hour. So what we have shown in this calculation is that if an object was traveling at a speed of 2.3 feet per second, that is exactly the same thing as traveling at a speed of 1.6 miles per hour. Okay, let's do our last part within this example. In this case, we want to convert 900 kilowatt hours per day into units of megawatt hours per year. So you might perform a calculation like this if you wanted to know your daily energy usage, if you wanted to convert that into your yearly energy usage. So let's start. We always begin by writing down what we know. We're given 900 kilowatt, and remember this is kilowatt times hours, so I'm going to write it that way. And this is per day, so we're going to write this as a fraction over 1 day. We need to multiply this by a certain conversion factor that will ultimately, in the end, give us a certain numerical value with units of megawatt hours per year. So now the big question is, what is this conversion factor? Well, let's look at the units we're starting with and the units we're finishing with. Key observation to make here is that hours appears in both the units we're given and the desired units, so we don't want to eliminate hours. Really what we need to do here is convert from kilowatts to megawatts and convert from days to years. We're not going to be able to do that with a single fraction. Our conversion factor here is going to have to be a product, actually, of at least 2 other conversion factors. So we're going to break this problem into smaller steps, just like we did in Part E. So we're going to jump down below here. We're going to write 900 kilowatt hours over 1 day. And we're going to convert units in steps. So first of all, let's deal with the kilowatts. We know we do not want kilowatts in our final answer, so we need a conversion factor that will eliminate kilowatts. The simplest conversion factor that we know is that 1 kilowatt is the same as 1,000 watts. So I'm going to write 1,000 watts, which would be 10 cubed watts, over 1 kilowatt. I know that this is the right conversion factor to get rid of kilowatts because I'll have kilowatts in the numerator and kilowatts in the denominator, so they cancel. And this leaves me with watts. Now, of course, we don't want watts in our final answer. We want megawatts. So we're going to need to convert from watts to megawatts. And remember that 1 megawatt is the same as 1,000,000 watts, or 10 to the 6 watts. So our next conversion factor that we're going to multiply by is going to have 1 megawatt in the numerator over 10 to the 6 watts in the denominator. So notice this is the right conversion factor to multiply by because we will have watts in the numerator, watts in the denominator, and they will cancel. So notice that getting this far, we have now megawatts in the numerator, which is what we wanted to have. And we also have hours in the numerator, so when we multiply megawatts times hours, we'll end up with the megawatt hours we wanted. Finally, we need to work with the days. We don't want units of days, we want units of years. So we're going to need to multiply by a conversion factor that relates days and years. We know that there are 365 days in a year, so that's going to be our conversion. I'm going to put the 365 days in the numerator because days occurs in the denominator at the beginning of this calculation, and I know I want to cancel out the days, so I want days in the numerator, days in the denominator, so that they can be canceled. This leaves us with years. So when we're all done, we've got hours and megawatts in the numerator over years in the denominator, which is precisely what we wanted back here. So we started off with our quantity over here. We have to multiply by 3 conversion factors in order to arrive at these units. So this conversion factor right here is actually the product of these 3 conversion factors. So let's finish this up. We need to multiply these 4 quantities together, which means we need to multiply the 900, the 1000, and the 365, and then divide by the 10 to the 6. When this is finished, you arrive at 328.5 megawatt hours per year. So what we have shown through this calculation is that if a person's daily energy consumption were 900 kilowatt hours a day, this would translate into an annual energy consumption of 328.5 megawatt hours of energy over the course of a year. Okay. The last 2 examples in this section allow us to just recap on what we've learned about manipulating units. So let's look at example 3.10. The expression below shows the units of 4 quantities that are multiplied together. So we've got one quantity here, 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 and here. The numerical values of these 4 quantities have been omitted so that we can just focus on what's happening with the units. So you would just have to imagine in your mind that there are numerical values associated with each of these. The question is, when you multiply 4 quantities together that have these units, what will be the units of the final quantity? Well, this is where treating units as though they were numerical factors is helpful. We can cancel units that are common to numerators and denominators, thus simplifying the units. If we look at the units in these 4 quantities, we can see that seconds appears in the numerator and denominator, and therefore we should be able to cancel it. Meters also appears in the numerator and denominator, as does seconds. So when we're done, the only units that haven't canceled out are the miles and the hours. So if we multiplied 4 quantities together that had these units, the answer would have units of miles per hour. All right. Let's look at example 311. The right side of the equation below gives the units for 3 out of 4 quantities that are multiplied together. So you have to imagine, here's one quantity, here's another quantity for which no information has been given, here's a third quantity, and a fourth. Again, the numerical values of these 4 quantities have been omitted. We're just looking at the units. So imagine we're multiplying together these 4 quantities, and you're only seeing the units here. And when you're done, these are the resulting units. These are the resulting units of your answer. In this example, the goal is to figure out what must have been the units of this quantity here. So the key to working this example is to understand that the units on this side, the right side of an equation, must be the same as the units on the left side of an equation. Once all common units have been canceled, the units on the left have to match the units on the right. So let's take a closer look at the units that are on the right side of this equation. Can we simplify the units here at all? Well, there seems to be one thing that can be done. Notice that days appears in both the numerator and the denominator, so that should be eligible for canceling. Are there any other units on the right-hand side right now that are common to the numerator and denominator that could be canceled? And right now the answer is no. So for right now we've simplified the units on the right side as much as we can. Now what we need to do is compare the units on the left side with the units we've got left on the right side. They have to match. So for example, notice we've got acres in the numerator on the left side. We have to have acres in the numerator on the right side, and we do. We've got them. We need to have person in the denominator we have person in the denominator on the left-hand side, so we need to have person in the denominator on the right side, and we do. We already have that. Finally, we need to have year in the denominator on the right-hand side because it occurs in the denominator on the left side, and we do have that. So the circled units appear on both the left and the right-hand sides of the equation. All other units on the right side of the equation have to cancel. So that means we have to deal with the pounds and the tons. These units here have to cancel, which tells us what this fraction here, what its units would have to be. This fraction is going to have to enable us to cancel out the pounds and the tons. So if we have tons in the denominator, we need to have a certain number of tons in the numerator. If we have pounds in the numerator, we have to have pounds in the denominator here. So with this fraction added, notice that the tons will cancel and the pounds will cancel. And so when we're all done, we will have an equation that has units of acres per person per year on the left side and acres per person per year on the right side. So again, this is a really important point. The units on the left side of an equation have to be the same as the units on the right-hand side of an equation once all of the units have been simplified and any common units have been canceled out.